Welcome students, I am Shakila, your science teacher, going to take the lesson Combustion and Fossil Fuels under the heading Fire, Extinguishing a Fire, Flame and Zonesofa Candle Flame. In the previous class, you have learned about what is combustion, some examples of fuels and fossil fuels such as coal, petroleum, natural gas. Then I explained about combustible substances that burn in air or oxygen to produce heat and light are called combustible substances. Then example, paper, wood, kerosene, LPG. Then non-combustible substances, so water, sand, glass and cement, etc. Then I have taken types of combustion. What are the types of combustion? Rapid combustion, explosion, spontaneous combustion. Rapid combustion means a combustion in which a large amount of heat and light is released in a very short span of time. Then example for that is combustion of LPG gas. Then explosion. Explosion is a combustion which is characterized by the sudden release of heat, light and sound accompanied by the liberation of large amount of gas. Example for that is bursting of firecrackers. The next we have seen about complete combustion. Before going to complete combustion, we have learned about spontaneous combustion, that is combustion in which a substance catches fire on their own without the application of heat. Example we have seen is white phosphorus. When it is exposed in air itself, it catches fire at room temperature. Then we have seen about complete combustion. Complete combustion means the combustion that takes place in adequate amount of air or oxygen and it releases carbon dioxide, water, heat and light. Then the next one is incomplete combustion, in which the combustion that takes place in inadequate amount of air or oxygen and results in the formation of carbon monoxide, soot, water, heat and light. Then we have seen about the conditions necessary for combustion. What are the conditions necessary for combustion? First one is presence of a combustible substance. Second one, presence of a supporter of combustion. Then the third one is attainment of ignition temperature. Also, we have seen another definition, inflammable substance. What are inflammable substances? The substances that catch fire very easily are called inflammable substances and they have low ignition temperature. Example, LPG, petrol, alcohol, nylon fibers, etc. Okay, today we are going to see a new topic called extinguishing a fire. You have seen the burning of fire, is it not? Yes. How will you extinguish a fire? For all types of fire, we cannot use water to extinguish it. So, according to the substance that is burning, the substance will be used for extinguishing. So, when we are pouring water on a fire, what happens? Water evaporates and it takes away all the heat from the fire, which in turn cools down below its ignition temperature. Then, can you pour water for extinguishing all types of fires? No. First of all, oil substances such as petrol, kerosene, diesel, when they are burning, we should not pour water. What is the reason? Because these substances are lighter than air and they do not mix with it. These substances are lighter than water, okay. These substances are lighter than water and they do not mix with the water. That's why what will happen? The water forms a layer beneath them and the substance will continue burning. So it will not stop the burning. So when you pour water for oily substances such as petrol, kerosene, diesel, etc., we should not pour water because the water forms a layer beneath under that and it continues burning. Then second one is water should not be poured over electrical fires, that is fire conducted or fire happened in the electrical appliances. Why do we not pour water there? Because if we pour water over electrical appliances that catches fire, it will conduct electricity and it will it will cause danger to the people, those who are trying to extinguish the fire in electrical appliances. So what should be done for this? So we can make use of carbon dioxide gas for extinguishing these type of fires. Now, fire extinguishers are of two types. They are carbon dioxide fire extinguisher and soda acid fire extinguisher. There are two types of fire extinguishers. One is carbon dioxide fire extinguisher and the second one is soda acid fire extinguisher. What type of fire can be, or what type of extinguisher is carbon dioxide fire extinguisher? Carbon dioxide fire extinguisher consists of carbon dioxide that is filled in cylinders and it is under high pressure. That is, carbon dioxide gas is filled in a cylinder with high pressure. Okay, so that is called carbon dioxide fire extinguisher. Then what do you mean by soda acid fire extinguisher? Soda acid fire extinguisher is a extinguisher which has a concentrated solution of sodium hydrogen carbonate and sulfuric acid. These two solutions are kept in separate compartments. Then when the fire is extinguished, or when the this type of fire extinguisher is used, what will happen? These two substances, that is sodium hydrogen carbonate and sulfuric acid, they come into contact with each other and they produce carbon dioxide and it will extinguish the fire. So this is the soda acid fire extinguisher. So we have seen about fire, how to extinguish a fire. Now let us see about the flame. Flame is a region where burning of fuel takes place, or a flame is a region where combustion of fuel takes place. Already you have learned about combustion. Combustion is a process in which burning of a substance causes heat and light. Okay, now a flame consists of many colors, or a flame is consisting of many colors. The flame, color of the flame depends upon the temperature and amount of air that is present and what is the substance you have taken, that is nature of the substance burning. So color of the flame depends upon three factors: temperature, amount of air available and the nature of the substance burning. Now whenever hydrocarbons burn, it will give a blue or yellow flame. Then the flame is consisting of three layers. Okay, so when a flame is there, we can see three colors in the flame. Okay, a yellow flame, a blue flame. First of all, we will see about a yellow flame. The yellow flame is also called as a luminous flame. Why is it called as luminous flame? The yellow flame only emits a lot of light, so it is called as luminous flame. The luminous flame is observed when there is a insufficient amount of oxygen, that is inadequate supply of oxygen is there, we will get the yellow flame, the luminous flame. That is, we can say in terms of combustion as it is an incomplete combustion. So yellow flame is formed due to the incomplete combustion of fuel. Now if you consider the temperature will be lower than the blue flame and it will leave a little black residue also. Okay, so yellow flame is a region where it emits a lot of light and it is an insufficient, or when there is an insufficient oxygen, we will get the yellow flame. Incomplete combustion takes place in this flame and it will also emit a or it will leave behind a small residue also. Now let us see about the second flame. Second is a blue flame. A blue flame is also called as non-luminous flame. Why is it called as non-luminous flame? Because it emits very little light, but it will give more heat. Okay, so it will produce more heat, but it will emit very little light. Then a blue flame is observed when there is a adequate amount of oxygen available. If suppose sufficient amount of oxygen is available, we will get blue flame. Now this blue flame, it will not leave any residue, or in this region there is no residue. Then another one is the black. It is not a flame. In the center of the candle or in the center of the flame there is a black part. Okay, it is the coolest part of the flame. Now, so that's all about the flame. So flame is a region where combustion of fuel take place. Then it is divided into two, that is yellow flame, it is called as luminous flame, and blue flame is called as non-luminous flame. Yellow flame emits a lot of light, blue flame emits a very little light, and yellow flame is available or observed when there is a insufficient supply of oxygen. We can say as a incomplete combustion. But a blue flame region is a region where adequate amount of oxygen is available and it is a complete combustion. Now let us see about the zones of a candle flame. What are the different zones of a candle flame? The outer zone, the middle zone and the inner zone. So candle flame consists of three zones. The outer zone, or it is otherwise called as blue zone, and the middle zone is called as yellow zone, and the inner zone is called as black zone. Now let us see the different types of zones in the candle flame. First one is the outer zone. The outer zone is otherwise called as blue, or the outer zone, the light will be blue color. It is the hottest part of the flame. So blue flame where it is observed, it will be the hottest part of the flame. Now what is happening in this zone? In this zone, wax vapors have enough oxygen to burn completely. That is, it is supposed to have complete combustion and it will produce carbon dioxide and water. Now this zone, blue flame or blue zone, emits a very little light. So this is the first part of a zone, or the first zone in the candle flame. So the blue outer zone is blue in color. It is the hottest part of the flame and it will release carbon dioxide and water, and in this region there is an enough supply of oxygen and it burns completely, and this zone emits very little light. What about the second zone? What is the second zone called? The second zone is called as the middle zone. The middle zone is yellow in color and it is less hot than the outer zone. Here we can find incomplete combustion of wax papers and it produces carbon particles. Okay, these carbon particles will glow and it will give a yellow color. Also carbon monoxide is released in this yellow zone or middle zone. Now how much amount of light is emitted in this yellow zone? This zone emits the most light. Light is produced more. Okay, the light is produced more. So this zone emits most light. That's all about the second zone, that is the middle zone. We will see about the third zone. The third zone is called as inner zone. The inner zone is black in color and it is the coolest part of the flame. Now in this zone, wax papers remain unburned and there is no oxygen. So oxygen is not available in this zone. So this zone appears to be completely dark and it will not emit any light. So the inner zone is the black in color and it is the coolest part of the flame, and in this zone wax papers wax vapors remain unburned and no oxygen is available. So this zone is completely dark and emits no light. There is no light in the inner zone. Now, let us see about the combustion of a wax candle. Now, suppose if you notice a wax candle flame, we will see the wick burns, and the wick, when it is burning, it stands in a pool of liquid wax. That is, around that wick there will be liquid wax. So that only we can say the wick burns and it stands in a pool of liquid wax. The second one is, there is a small portion of unburned wick between the flame and the liquid wax. So you can find between the flame as well as the liquid wax, you can see a unburned wick. What is that wick? That is the thread-like substance that is black in color. That is unburned wick. So there is a small portion unburned wick between flame and liquid wax. The third point is, the liquid wax is trapped in a cup of solid wax. So the liquid wax will be situated like a cup in the solid wax. Then the fourth point is, the liquid or solid wax never catches fire. So the liquid or the solid wax will not catch fire. So these are the points you can see when a wax candle is burning or during combustion of a wax candle. Now, the wick is burning, but it cannot be the only substance that is burning. What are the substances burning to be addition to the wick? The wax vapors also will burn with the wick. So if you lit a match, if a lit match is brought near a little above the candle wick, immediately after the candle has been blown up, it is noticed that flame from the match jumps the gap and reignites the wick. So this is due to the wax vapors rise from the wick immediately after the candle is blown out and burning match reignites them. So this is the reason we will see during the combustion of wax candle. Okay, so we can say that wick is burning, but at the same time wick is not only burning, but the wax vapors are also burning. So if a lit match is that is, if a matchstick is brought near the candle, little above the candle wick, what will happen? Immediately after the candle has been blown out, it is noticed that the flame from the match jumps the cap and it reignites the wick. So this is because the wax vapors rise from the wick immediately after the candle is blown out and the burning match reignites them. Okay, so we have seen about extinguishing a fire, flame, zones of a candle flame and combustion of a wax candle. So first of all, there are two types of fire extinguishers. One is carbon dioxide fire extinguisher and another one is soda acid fire extinguisher. Carbon dioxide fire extinguisher consists of a cylinder which is filled with carbon dioxide under high pressure. Then soda acid fire extinguisher is a extinguisher which contains two compartments. The one compartment is filled with sodium hydrogen carbonate and the other compartment is filled with sulfuric acid. So when they do fire extinguishing, the two substances or the two solutions will come in contact with each other and produces carbon dioxide. So the carbon dioxide gas produced extinguishes the fire. Before seeing fire extinguishers, we have to see whether this water is applied for all types of fires. No, water will not be poured over burning petrol, kerosene or diesel. What is the reason? Because petrol, diesel and kerosene are lighter than water and they do not mix with the water. So as a result, it will form a layer above the water. So water will be lying below and a layer will be formed above, and it will continue to burn. So we cannot pour water over oil fires. The second one is, while a fire is created in electrical appliance, can you use water there? We should not pour water over electrical appliances, because the water itself is a good conductor of electricity. So it conducts electricity and it will support or it will catch fire, or it will cause some damage to the people who is trying to extinguish the fire. So these are the things you have to know about the extinguishing of fire. Then we have seen about flame. What is a flame? Flame is a region where combustion takes place. Flame is a region where combustion of fuel takes place. Now this flame consists of two regions, and the color of the flame depends on the temperature and the amount of oxygen or air available and the nature of the substance that is burning. Whenever hydrocarbons burn, it will give a blue or yellow flame. Now yellow flame is also called as a luminous flame, and it emits a lot of light. A luminous flame is due to the insufficient supply of oxygen. We can say that yellow flame is accompanied by incomplete combustion. The next one is blue flame. Blue flame is called as non-luminous flame, and it emits a very little light, but it is the hottest part of the flame. Okay. Then blue flame happens due to the adequate amount of oxygen available. We can say that it undergoes complete combustion. Then next we have seen about the zones of a candle flame. There are 3 zones in a candle flame. The first zone is the outer zone. The outer zone is blue in color, and it is the hottest part of the flame. And in this zone, the wax vapors have enough oxygen to burn completely. We can say that it undergoes complete combustion and produces carbon dioxide and water. And this outer zone emits very little light. Okay. The second zone is the middle zone. It is yellow in color and it is less hot than the outer zone. Here we can say the yellow color is due to the incomplete combustion of wax vapors. The third zone is the inner zone, and it is black in color. It is the coolest part of the flame, and in this zone wax vapors remain unburned. The wax vapors will be there without burning. There is no oxygen, that's why it is very dark, and it emits no light. There is no light emitted, that's why it is black in color. So we have seen all the zones of a candle flame. Now next is combustion of a wax candle. When you observe a candle flame, we can see or we can notice 4 points. The first point is the wick burns and it stands in a pool of liquid wax. The second point is there is a small portion of unburned wick between the flame and the liquid wax. The third point is the liquid wax is trapped in a cup of solid wax. The fourth point is the liquid or solid wax never catches fire. When a flame is there, we feel that wick is only burning. The wick is not only burning, at the same time the wax vapors are also burning in addition to the wick. So to show that, if you bring a lit matchstick just above the candle wick, immediately after the candle has been blown out, it is noticed that the flame from the match jumps the gap and reignites the wick. What is the reason? This is due to that the wax vapors rise from the wick immediately after the candle is blown out, and the burning match reignites them. So that's all today's portion, children. So on Friday I am not able to conduct the Zoom meeting. If possible, we will see the other question answers everything in the Zoom meeting, and some question answers I will send in the PDF. Thank you.